Hello again. Today we'd learn the following: what lambda expressions are, why we need to use them, and when we should use them. Okay, so what are lambda expressions? They are a shorter and more concise form of anonymous methods. Lambda expressions are anonymous methods but represented in a much more concise manner. So it all revolves around this lambda operator, which is read as goes to. The If you see on your screen, you see the syntax, which shows the parameters on the left-hand side, the lambda operator, and the expression. We'll go to the details of this in the next slide. So the slide shows the parameters on the left, which means these are the delegate parameters, and the expression to the right is the expression associated with this delegate. So in the case of anonymous methods, we always had some statements which were towards the right hand side and were associated with the delegate. Before we go into how to represent a lambda expression, let's see how anonymous methods are represented. Here we have a delegate and brackets, which shows that this is a delegate which has no parameters, with a block of code called the anonymous method associated. In the case of lambda expressions, we do not require the delegate keyword. Okay, so if we look at our screen, how we instantiate the delegate keyword is missing. We just have the brackets, lambda operator associated with do something. Do something is a function. It returns void as the same as expected by the delegate. Delegates can be represented in much more simpler ways. We'll come to that in the advanced topics. Okay, so this is how a lambda expression is used to declare a delegate, instantiate a delegate, and use it. If you see, we have the next example for a single parameter lambda expression, which is expressed as underlined. So this is how we instantiate it. X is the parameter, and we want to return x plus 1. So it's very simple. In the case of multiple parameters, we have x, y, and we just want to add x plus y, and we have a very simple and a single line logic, x plus y. So this was what lambda expressions are, and let's see why and when we need to use them. So why we need to use them is because they are simple and a very concise way of representing anonymous methods. Not only that, the simplest way to declare delegates. So it's nice to use from the developer point of view. Secondly, lambda expressions are very powerful when it comes to building expression trees. This is a detailed topic that we would be covering later, and they also form the basis of a couple of declarative functional languages like F#, which is incorporated into the framework, .NET framework, and previously we had other languages like Haskell and ML and so on. So it focuses more on declarative logic, meaning you can just focus on what you want to do. I want to add two numbers, that's it. I'm not interested which class they are a part of, which structure they are part of, what is the type of the variable, and so on. I've got two values, I want to add them. So you focus on what needs to be done. This actually reduces the amount of code that we write, which reduces the noise around the logic. The examples will outline the differences between anonymous methods and lambda expressions. You can notice the reduction in the number of lines of code. If you see in the lambda expressions, the type is inferred automatically. We do not provide the type of the variable in the parameters. The next example outlines the similarities between lambda expressions and anonymous methods. As you can see from the comparison on your screen, there's no difference except the lambda operator. Also, the point that needs to be highlighted here is we can make use of reference and out parameters in lambda expressions and anonymous methods just the way we do in named methods. Let's also look at the lambda rules and the scope of variables while working with lambda expressions. A variable that is captured will not be garbage collected. until the delegate that reference it becomes eligible for garbage collection. Okay, so the second point is variables introduced within a lambda expression are not visible in the outer method, but if a method that encloses a lambda expression has some variables declared in the scope of the function, those would be accessible within the lambda. A lambda expression cannot directly capture a ref or out parameter from an enclosing method. It means that even though lambda expression accept ref and out parameters, but the function inside which the lambda exists, if the function expects a ref or out parameter, this parameter cannot be used within the lambda expression. A return statement inside a lambda expression does not cause the enclosing method to return. Seems self-explanatory. You just return from the lambda expression, not its enclosing function. So the next point says that you cannot have any jump statements like go to, break, or continue, or any statements that make you jump to a target that is outside of the lambda expression. So jump statements are discouraged in lambda expression. They'll give you a compile time error. And now we have an overview of the types of lambda expressions that we would be covering in the forthcoming chapters. They are expression lambdas, statement lambdas, both of which we have seen in our examples. We'll go into details. Async lambdas, type inference lambdas, and lambdas using standard query operators. I'd request you to have the latest .NET version installed on your systems, as async lambdas were introduced in .NET 4.5. Thank you very much for watching this video. Hope you enjoyed it. Please do take very good care of yourself and meet you back in the next chapter. Bye-bye.